Kingsa.com. Hello, I'm Professor Chris Ferguson, and this is Objects Only. Welcome to the lesson on Java Objects. A class is to an object, ... This is like that old SAT question. A class is to an object like a blueprint is to a house. What is a blueprint? It's a complete specification. It's a set of plans for creating a house. But it doesn't become a house until someone takes that blueprint and builds a house from that blueprint. Well, a class to an object is the same relationship. A class is a definition, a template, and somebody has to build the class first, and then we use that class to create an object. It's the same relationship like a recipe is to a cake. A recipe is a list of ingredients and a set of instructions on how to make a cake. Once again, it doesn't become a cake until somebody executes that recipe and creates a cake from the recipe. Well, the class to an object is the same thing. Somebody designs a class, somebody writes a class, and then you use that class to create an object. So why study objects first? We haven't done a lesson on classes yet. Why would you study an object first if you need a class in order to create an object? Well, first is we've used objects already. From the first day of Java programming, you're using objects. There's no way around it. The second thing is there are a lot of built-in classes to Java. You don't have to write the classes. You could use the ones that Java provides it. So it's not such a leap to do objects first. An even better or bigger reason is understanding objects will make learning classes easier. Classes is typing in code. Objects is using that code. So it's sort of like learning how to drive a car before you know how to repair a car. You got to understand how to drive a car before you really understand how the engine works. We're going to understand objects first, and then we're going to go and study classes. Objects are variables that have variables and methods. Think about that. Objects are variables that have variables and methods. Objects have two parts to them, two major parts to them, a set of variables and a set of methods. Let's look at the string class to see what I mean. We're going to create a string hero equals new string Thor. You may not know it, but every time you create and use a string, you are creating an object. The string is the class that's built into Java that we use to build an object out of that class. Now, objects have variables. Well, obviously the variable in a string object would be that data, the THOR, that we store in that object. Objects have methods. String objects has methods like char at or character at, length, and toUpperCase. Objects have variables and methods, and you can definitely know what the variable of a string object is. It's the data you're storing in the object, and there are methods you can execute with that object. This second line of code is why we sometimes don't realize strings are objects. This line of code actually does the same thing as the line above. The string type is so common, Java automatically creates the object. Typically, as we move forward, we'll use the new command to create objects. But with strings, Java said we'll automatically do it. So this line of code basically gets translated to this line of code automatically for you. There are some slight differences that we'll study later, but you don't have to use the new operator to build a string object. Now let's look at this line of code very carefully, piece by piece. I'm going to start with hero. Hero is what we call an object reference variable. It is an object. A lot of people will look at this and say that's an object, but technically it's an object reference variable. An object reference variable is a variable that points to or refers to an object. The object itself doesn't technically get stored in hero. A value that tells you where that object is in computer memory is stored in the reference variable hero. We're going to start with this reference variable hero, and then the dot. The dot operator says go inside the object and access a variable or method. So the dot says follow this line right here. I go to hero first, and then the dot says let's go inside the object. The dot takes us inside the object. Once we're inside the object, what do? Well, objects have variables and objects have methods. In this particular case, we're going to use the dot to come inside, and we're going to access the char at method. Methods define what an object does, and this method will get the character at position 1. Find me the character at position 1. Now strings, just like arrays, start at position 0. So the H is actually the character at position 1. We're going to take that H and send it to the character variable C. That's what a method does. It performs some action on this data and returns a result to the user. The character at position 1 of the string is an H. Let's do it again. Let's make sure we understand how objects work and that objects are variables that have variables and methods. Methods define what the object does. In this case, the length method will return the number of chars in the string. What does that mean? Once again, we'll start with the object reference. Remember, here is a reference variable. The dot says go inside the object the reference points to and execute the length method. The length method will literally count the characters. 1, 2, 3, 4 characters. Return a 4 to the caller and assign it to the variable length, or len. That's often what a method does. Extract some information from the object and assign it to the variable len. Getting the picture? This object reference variable, hero, has access to variables and methods. We're going inside and executing methods. Next up is to uppercase. This converts the data stored in the variable to uppercase. This really highlights that fact that we are storing data or variables inside this object. We have some data stored in the object, Thor with an uppercase T. We want to convert this whole string to uppercase now. Go to the hero variable. The dot operator says go inside this object and execute to uppercase. Well, what does to uppercase do? It takes all these letters and makes sure every single one of them is an uppercase letter. And there it is, T-H-O-R in uppercase. What do we do with it after it returns the uppercase string? We assign it to a variable called upper. Upper is also a string reference. It points to this new string object containing Thor in uppercase. The point here is we need to be object aware. What does that mean, be object aware? Understand that the new and the dot operators are signals that we're using objects. Whenever you see this new operator, it literally means give me some new memory to hold an object. And that's what's going to happen. It's going to allocate this chunk of computer memory to hold an object. Notice the dot operator. Whenever we see that dot operator, the first thing you got to think of is this is an object reference. And this is an object method. Now, how do I know that is an object method? Well, it's the parentheses that clue you in. Whenever you see a parentheses after that dot operator, you know what's in between is a method. This is the char at method. This is a length method. This is a to uppercase method. We know to uppercase is a method because of those parentheses right there. Be object aware. Realize when you're reading code what's an object and what's not an object, because it varies quite differently. When you're using a non-object, you have no methods. You don't use the dot operator. But if you do have an object, be aware that that object may contain variables and it may contain methods, and you use the dot operator to access those variables and methods. Have I said this enough? Objects have variables. Most, if not all objects, will have 1, 2, 4, 10 variables as part of the objects. Objects have multiple variables associated with them. Objects have methods, char at, length, to uppercase. The methods define what the object does. These are the actions the objects will perform for you. Every object has a list of methods. Now, how do you know what the variables and methods are? Well, I hate to tell you this. Read the documentation. If you went out to the Google and typed out Java string class, the first or second link onto that would be to the Oracle documentation for the Java string class. You click on it, scroll down a little bit. If there's variables you have access to, it'll show you the variables. And then there'll be a list of methods. These are the methods you can call if you have an object. You really don't need the details of how a string is created or implemented. You just have to follow the pattern. I have a class, it has some variables and methods. Let's build an object. Let's put some data into that object, and then let's call the methods to use the object. All right, so that's the introduction to objects using the most commonly used type of object, which is a string object. Remember, string is the class. We build an object and assign it to the object reference hero. Array objects. Another type of objects we've been using all along is an array. Java arrays are objects. They just don't look like objects, and I put look in quotes for a reason there, because often when we're using array, we don't use the dot operator. Typically what we do when we're using an array is we use the square brackets here. This says I want to go to the array numbers, and in slot 2 of the array numbers, I want to store 99 into that array. That is how you put data into the array, using square brackets and an index or a subscript. How do you take data out of the array? Once again, we use square brackets and an index or a subscript. Take that 99 that I stored in slot 2 of the array, extract it from the array, and assign it to the variable x. This code right here does not look like an object to me. We're not using the new operator. We're not using the dot operator. It doesn't look like an object. But there's a reason for that. Java uses square brackets, so array access is similar to C or C++. You may or may not know this, but Java is derived from C++. Well, what does that mean? It means the designer, the creators of Java, started with the C++ language. And they said, let's copy the C++ language. Let's take out some stuff we don't like. Let's add some new stuff that we do like and replace the stuff we took out, and Java was born. Java was created from the C++ language, and one of the decisions they made is we will handle arrays just like they do in the language C and C++. So a new programmer that's used one of the older languages would get to Java, and arrays would look and feel like they did in the older languages. But they're not the same. In Java, they decided to make the arrays objects. Therefore, we can do some other things besides the square brackets. Once again, objects are variables that have variables and methods. An object is like a multi-part variable where you could have several pieces of information stored in that object rather than one piece of information. It's very clear what gets stored in the variable portion of an array object. It's the numbers of the array. The new operator is one way to spot an object. New allocates memory for an object. And that's exactly what we're going to do. This time we're going to say new int square bracket 5 into square bracket. Allocate me an object to hold 5 integers. And you can see when I do that, it goes ahead and with this syntax allocates 5 empty slots or 0 filled slots. Objects have variables. Objects can hold multiple variables. And we are obviously storing 5 pieces of data, at least, in this object. See those 5 zeros? With this syntax, it will allocate 5 integers, and they will be 0 filled. But remember, this variables up here is plural. That is not the only thing stored in the variable section of this object. There's also an extra variable here called length. And length tells us we have allocated 5 items in this array. Numbers equals. What does that mean? Remember, numbers is what we call a reference variable. It points to or refers to the object. and the equal assigns the object to the reference. So the new int5 created this object in computer memory, and then when we said assign it to numbers, it attached this line right here. Numbers is a reference variable. It points to an object, and the reason it points to it is because of that equal sign. The syntax above will allocate an empty array filled with zeros. This new syntax will allocate the same 5 slots, but this time fill it with certain values. It's an alternative way to create an array. Fills the slots with values, not zeros. Just like with a string, you can create an object without using the new operator. Quite often, new students get a little confused by strings and arrays because you don't need to use the new operator to create those objects. However, with this syntax, it's called an initialization list. If you give it an initialization list, it will create the object. It will count 1, 2, 3, 4, 5 items in the list, and then fill those slots with the values you see here. So 3 is put into slot 0. 7 is put into slot 1. 1 is put into slot 3, and so on with the 8 and 6. This syntax creates an empty array. This syntax creates a filled array, an array with data in it. Notice the second variable. There are multiple pieces of information stored in this object. Objects are variables that have variables. This is all one line. It starts with system.out print line and it ends with this parentheses curly brace down here. But what I want to highlight is what I'm doing here in the red box. Numbers.length. What we're doing here is we're going to access the length variable. Objects have variables. Remember, I've been saying that 10 times. I've said it already. Objects are variables that have variables. And this is specifically a variable in this object. This line of code will print the number of slots is 5. Remember what the dot operator does. Start with the numbers reference variable. Start with this variable right here. The dot says go inside the object. Follow this link. Follow this line from the reference variable down into the object. When you're in the object, access something in there. The fact that there's no parentheses after this means length is a variable of the object, not a method. And that's what we're doing here. Sometimes I think of objects as mega variables. It's a variable that can have multiple variables inside of it. There's a big difference on what we're doing here. See that parentheses right there? That applies for the print lines. That goes with that. It has nothing to do with length. If you see the dot operator followed by something without parentheses, you are accessing a variable in the object. Just to remind you how methods work, methods do have parentheses. So I'm going to go to numbers.clone, access the clone method. Notice the parentheses after the word clone. Objects have methods. We are accessing a clone method. The clone method, as the name implies, will make a copy of the object. I'm going to go to numbers. I'm going to access inside of it using the dot operator, the clone method. And what the clone method does is make a copy of the object. When I'm done making the copy, I will assign the copy to a new reference variable called num2. And you can see that num2 points to the clone or the copy of the object. The equal attaches the object to the reference variable num2. I want num2 to point to this object, just like numbers points to that object. The clone makes a copy. I have 2 objects. I now have 2 reference variables. Learn the patterns. New creates an object. New creates objects. Whenever you see new being used, assume this is a reference variable that will point to an object. Reference.variable with no parentheses. When you see the dot operator used, followed by something without parentheses, you are talking about accessing a variable inside the object, like the length variable. Reference.method with parentheses after it means clone is a method. So I'm going to go to the numbers reference variable. The dot says go inside, and the clone with parentheses says access this method. Objects are variables that have variables and methods. And the first thing you have to learn is to access a variable. I use the dot operator and no parentheses. To access a method, I use the dot operator and there will be parentheses. When you're reading code, not just this code, but code from the book, code on exams, code in your programs, learn to spot the objects. I just spotted an object. System.out must be an object. Now, why do I know system.out is an object? Well, first of all, the dot operators is a big clue. The second thing is, after that second dot, I access println, and there's parentheses after that. Clearly what I'm doing is using this object in the red box to execute this method, and it's got to be a method because there are parentheses after it. When you're reading code from this point on, I want you to start analyzing the code and knowing what is an object and what is not an object. Primitive versus reference types. What is that? Variables come in two flavors. We have primitive types, which are not objects, int, double, char, boolean. These variable types are not objects. They allocate a very small amount of memory and store data directly in that memory. The second flavor of variables that Java has are called reference types. These are things that will be or currently are objects. Reference types point or refer to objects. Now, string is an object, as we looked at. Arrays are objects. Almost anything that has an uppercase first letter. See that S? See the A is uppercase? See the E is uppercase? See G? In Java, the convention on a class is to make the first letter uppercase so you can spot it. These are all classes. Classes build objects. Any variables of this type must be objects. Memory is allocated for the reference and the object. As we've seen with the previous pictures, objects are more complicated than primitives. Primitives are simple. One piece of memory, store the data in it. Objects are more complicated. You have to allocate a reference, and then the reference points to the object. Then the object can have multiple pieces of data stored in it. Let's start simple. An int is short for integer. It's about as simple as a thing you can create in a computer. I'm going to create an int score, and I'm going to allocate a small piece of memory to hold an integer. Score is an int, which takes 4 bytes of memory in Java. If this is a local variable, it's allocated when the method runs, and it has an undefined initial value. The reason I put 2 question marks in there is if this is local, meaning it's declared inside of a method, it will not have a value after the declaration. It's undefined value. However, if this was a global variable declared at the top of the class, it would be allocated when the object is created, and it would have an initial value of 0. So depending on the kind of variable, local or global, it may or may not have an initial value. Double money semicolon. Money is a double. In Java, that's 8 bytes of computer memory. If it was declared as a local variable, it would be allocated when the method runs or executes, and it would have an undefined initial value. If this variable was defined as a global variable at the top of the class outside the method, it would be allocated when the object was created, and it would have an initial value of 0.0. Global variables declared at the top of the class outside of the method are initialized with the value of 0. Local variables do not get initialized. Char rank equals single quote B end of single quote. Rank is a char, 2 bytes of memory. I put a question mark there. They're talking about making it 4 bytes of memory. I hope it stays 2 bytes, but that may become bigger in the future. If it was a local variable, this variable would be allocated when the method executes. Local means a variable is declared inside of a method. These get created when the method runs. If it was a global variable, it'd be allocated when the object was created. No doubt in this case, local or global, it will have an initial value of b. If when you're declaring the variable char rank, you assign it a value, then you don't have to worry about the initial value. You know exactly what it's going to be. Score equals 100. What we want to do is access the score variable and assign it the value 100. Values are stored directly into primitive variables. What do I mean by primitive variables? Primitive variables means it's so small, it's so simple, Java allocates just one piece of memory, and when you put something in that memory, it stores it directly into that variable. You could have also assigned it a math result. Once we have an initial value in there, we could say a score equals score plus 10. If this were to execute, it would extract the 100, add 10 to it, and store the 110 back into that variable. Variables are there to store values, and in primitive variables, you store them directly into the variable. Money equals 24.50. Assign the value $24.50 to the money variable. Once again, notice how values are stored directly into the variable, into primitive variables. You can also retrieve the contents of a primitive variable. If I were to print system.out, print line, cash colon plus money, it would extract the 24.50 and print it after the variable cash. That's what primitive variables are. Very, very simple, small pieces of memory, and you store the data directly into them and pull the data directly out of them. Now, reference variables are very different. Reference variables will be objects. They don't have to be at the very beginning, but they do store references to objects. Reference variable means this variable is going to be dealing with objects. Now, string is a class. I know string is a class. See that uppercase S? Java's convention on classes is to make the first letter uppercase. So it's a little hint that this is a class and this will be an object when we do it. A reference variable will allocate 4 to 8 bytes of computer memory and will have an initial value of null that indicates the object has not been created yet. We've said this before. References point to or refer to objects. We've just declared the variable here. We haven't created the object yet. So the value null in the reference variable tells you I have not been assigned an object. Let's assign it an object. Name equals Mario. In Java, all you have to do is assign a string literal to an object variable, and it will allocate and build the object for you. Assigning a value to the name reference variable allocates memory for an object, then connects or points that reference to the object. Interesting. So whenever I use a string literal, Java automatically allocates an object for you. The equal sign says, you know that object you just created here? I want the name reference to point to or refer to that object. It literally attaches the reference to the object. I need you to understand this. Object's memory is different than the reference memory. The reference points to the object. The object is the thing that actually holds the data, or Mario. Notice that the value Mario is not stored here. It's not stored in the name variable. What's stored in the name variable? A reference to an object. The location of the object is stored in the name variable. Also remember this line of code is the same thing as if I'd written name equals new string Mario. Kind of like this syntax because it's a little clearer that we're building an object. But in this case, it didn't matter whether we did it this way or that way. We'd get a string object containing Mario, and name would reference it or point to that object. Enemy space monster semicolon. I am declaring an object reference of type enemy. What does that mean? Enemy is a class. Monster is a reference variable. Reference variables allocate a small piece of memory, 4 to 8 bytes. The initial value of null, see that null in the monster reference variable, indicates an object has not been created yet. You can declare a reference variable without an object, and that is what we've done here. Now, a very common error that beginning Java programmers see is something called a null pointer exception. This is caused by this value null in the variable here. If I were to try to go to the monster object and access a variable or method inside of it, I'd get a null pointer exception at this point because monster has not been assigned an object yet. Whenever you use an object reference variable that doesn't have an object, you get that null pointer exception. Monster equals new enemy and pass it 20, 40, and what are we doing here? We're assigning a value to the monster's reference variable. This allocates memory for the object. There's our new command. New says give me a new object in computer memory. See these values 20, 40, 50? They are parameters to the constructor for enemy. So the variables x position, y position, and health, these will get assigned to the object's variables. Notice that these values 20, 40, and 50 are not stored in the monster variable. They're stored in the object itself. You store the location of the object in this variable, and you store the data in the object itself. Notice two different ways to create an object. String does not require name equals new string, Mario. You can just automatically assign it by saying double quote Mario and a double quote. We use the string so much it's done for us. Other classes that we write, like enemy or gun, those often require the using the new operator. Java will automatically create a string object without new. Java will automatically create an array object without new. But when we start writing our own classes, like enemy and gun, we are going to have to use the new operator to create an object. Gun weapon equals new gun, parentheses. May not look like it, but this is a variable declaration. See up here when we said char rank equals B? That's a variable declaration with initialization. We're declaring that rank will be a character, and after it allocates space for rank, it will assign a B to that character. We're declaring that weapon will be a gun reference variable, but after we create that, we will automatically assign it an object of type gun. Declare and assign an object to the weapon reference. This allocates memory for both the reference and the object at the same time, then connects or points the reference to the object. The values are defaults from the gun class constructor. Constructors are methods that help build objects. This is called the gun constructor, and it will initialize the gun object before assigning it to the weapon's reference variable. Now, for whatever reason, it decided that the type of the weapon would be a pistol, the caliber would be .45, and the number of bullets, or ammo, would be 6. These are what we call default values. When you call the default constructor, you're saying, go ahead, constructor, you assign the default values to the variables. It's very different than up here. Up here, when we created enemy, we told it what we wanted the values of the variables to be. In this case, we did not specify what we want, so we got what's called the default values. Primitive types like int, double, and char are small fixed amounts of computer memory, and the values are stored directly into the primitive variables. Reference types, name, monster, and a weapon, these are reference variables. They need memory for the variable, this memory right here, and they need memory for the objects, this memory right here. The value in the reference points or refers to the object in computer memory. Primitives are one single piece of computer memory. A reference with an object attached to it is two separate distinct pieces of memory, and the reference points to or refers to the object. It's important to understand the difference between a primitive and a reference type. Once again, learn to spot the clues. When you start seeing the new operator used, that's telling you that's probably a reference. When you see these uppercase first letters, uppercase S in string, uppercase E in enemy, uppercase G. Now that is just a convention, it's not a guarantee, but that generally indicates this is going to be a object reference variable. The get set pattern. A pattern is something that repeats itself. Objects are megavariables. They contain multiple pieces of data. Get and set methods, also called getters and setters, follow a very clear pattern. A set method puts data into the objects. Get methods pull data out of the objects. Set says put some data inside my object variables. Get says pull that data out of my object variables. We study the pattern because lots of Java built-in classes and objects follow the same pattern. Once you spot the patterns, you understand the objects. Earlier in this lesson, it was explained. A class is the blueprint or template for creating an object. So let's describe a class car here. There's really only two things you need to know about the class car. What are its variables and what are its methods? But you don't need to know all the details about the class to use an object. You just need to know the variables and or methods. If you were to Google Java string class, or Java scanner class, or Java array class, it would tell you what you need to know to build and use those objects. You don't need to know the details on how an array stores the data, or how a string stores the characters. You just need to know what those variables and or methods are, and you're off to the races. Remember, they follow very simple ideas. You use new to create an object, you access a variable, you access a method. As we advance, knowing the methods will become more and more important, but keep in mind those methods are there to set or get values into the object variables. Quite often what the methods do is they manipulate the variables of the object. And you need to have a keen understanding of, once I build an object out of class car, what is the data stored in the object? And what are the methods that will perform actions on that data? Objects can represent real-world things. Many people start object-oriented lectures by saying an object will represent something. I'm going to have an object to represent a tree, an object to represent a house, an object to represent a bank account. In this case, I decided to use the class car. Car is a very well-known example. We've all driven or ridden in a car. But they also represent a very game-oriented topic, right? If you're talking about a racing or a grand theft type of video game, you're going to have a class car that you build as part of that video game. So let's think of car right now as sort of the real-world thing, the thing you drive to school in, and understanding class object design. Variables are the things that describe what the object is. What the variables of an object should be is that key information that describes what we're building, that real world object. Now cars have a make, they have a year, they have a cost. That is the critical information that defines what a car object is. That's what the variables should be. Quite often when I see beginner programming, they'll put variables in here like int temp. Int temp is not a variable that belongs here. Temp doesn't describe what a car is. Make, model, year, cost, mileage. The key information that describes a car, that's what the variables of the car class / object should be. The variables make, year, and cost describe what a car is. The methods. The methods define what the object does. Methods define what the object does. Set methods let car objects insert data into the variables. It's what they do. I build a car object. I need a way to put information into these variables. I'll call set methods to insert information into my car variables. Get methods let car objects return the data stored in the variables. Getting data out of the object is something a car object does. It's what they do. When I'm designing a class like car, I often start with two lists. Do one list that describes what the object is. That's the information I want to store in the class. That is my list of variables. The second list I write when designing a class is what actions will the object do. The actions that I want the class / object to do, that is the list of methods I need to write for my class. Objects are variables with variables and methods. The first thing I want to understand objects is what are the variables, what are the methods. The variables define what the object is. The methods define what the object does. Car, my ride. What are we doing here? We're going to use this class car to build a car object and use the car object. Once again, I don't need all the details of the car class. I just kind of have to have an idea what the variables are and a list of what the methods are. So what we're going to do on this line is we're going to declare a type car object reference variable named myRide. It's important to understand that this line of code right here does not create an object. It creates a reference variable. It creates a variable that will point to or refer to an object, but the object itself has not been created by this line of code. It will contain the value null to indicate it does not yet have an object. Null is the value that's stored in a reference to say I do not have an object yet. MyRide equals new car. That new should be a big giant hint by now. That new is saying I want a new piece of memory to hold a car object. The new operator creates the object and allocates the variables. See, make, year, and cost? Those don't get created until we build an object, and there they are, make, year, and cost. Car with two parentheses after it is what's called the default constructor. See these parentheses there? That means we are calling the car constructor method, and what default constructor does is it puts default values into the variables. So make gets default of null, year is 0, cost is 0. Numeric variables tend to have a 0 in them. Reference variables have null in them by default. Unless the designer of the class puts a specific value into these variables, they will be zeroed out. The equal operator assigns a value to the reference myRide that points to the object created. What does that mean? New car is what created the object. After the object is created, I want to assign that object to the myRide variable. It's connecting. See this line here from myRide to the object? See the arrow right there showing I'm going from here to there? That is what makes the connection between the reference variable and the object itself. References are two separate pieces of memory. The reference variable points to the object, and the object is its own memory. Objects tend to take larger chunks of memory. Reference variables are small pieces of computer memory. I'm going to be a little redundant again. Remember on some of those previous slides I showed you two ways to do the same thing. I'm going to do the same thing here. I'm going to do it once by accessing the variable, and then I'm going to do it again by accessing methods to do pretty much the same thing. Now in this box we have two lines of code. MyRide.make equals forward and MAK equals MyRide.make. What we're going to do here is we're going to assign a value to an object variable, extract the same variable from the object. What are we doing here? Well, notice that there's no parentheses after the .make here. Not here and not here. What does that tell you? That tells you we are directly accessing the variable inside the object. So I want to go to the myRide reference. The dot says go inside here, and we want to directly access the make variable. On the first line of code, we assign the value forward to the make variable. On the second line of code, we extract forward from myRide.make and send it back and assign it to the variable MAK. Can we do this? Other languages like JavaScript and C# languages often allow direct access to the variables of the class/object. However, Java not so much. The class designer in Java gets to decide if access is allowed. You will not always be able to directly access the variables of the object. So what we're going to do is show you an alternative to it. Good object-oriented programming design says make the object users call a method. Good object-oriented programming design says rather than directly assigning values to make variables and directly extracting the make variable from the object, we are going to have to call methods to do it. And that's what I mean by redundant code. These two lines of code basically do the same thing as the previous two lines of code. They both insert data into the object and extract data from the object. What do set methods do? They assign values into object variables. The parameter value Honda is passed to the method and assigned to the make variable. If you look at this myride.setMake here, go to the myride reference variable, the dot says go inside of it, and run the method setMake. SetMake will take this Honda and put it in the make variable, and that's why it overrode the value Ford that was in there before. Get methods. Get methods return values from object variables. Variables make value Honda is returned to the caller and then assigned to the variable make. What is this line of code doing? It says go to the myride variable. The dot says go inside the object and run the getMake method. The method will take Honda, send it back to the caller, and assign it to this variable make. I need you to understand that these two lines of code do almost exactly the same thing as these two lines of code. These two lines of code say directly access the object's variables. These two lines indirectly access the object variables by calling a method to do the same thing. Objects have variables and methods. And what I'm doing with this example is saying, hey, when you're ready to access the variables, do it this way. When you want to access the methods, do it this way. Set patterns. Again, this slide is all about the patterns, and I want you to recognize the patterns. Set methods have an input parameter the same type as the variable it is setting. The pattern is hold, make is a string. So if the variable make is of type string, the set method will have a string parameter, and that string parameter will be the new value I want assigned to the make variable. Get methods have an output or return type the same as the variable it is getting. Once again, the pattern holds. This one returns a string. If getMake is going to grab the value in the make variable and return it, you better return of type string. These three arrows here, make is of type string, so the parameter to setMake has to be type string. Make is a type string, so the return value of getMake has to be a type of string. This is not a coincidence. If that's string, then this has to be string, then this has to be string. SetMake has a string input, getMake has a string output because make is a string variable. There's also a name pattern going on here. The variable is named make. So we're going to call the method setMake and getMake. I call this setMake because it sets the value of the make variable. This is called getMake because it gets the value of the make variable. Let's do it again for the other variables. But this time they'll be slightly different because the type of the variable is different. This is an int year. So I'm going to say myride.year equals 2016. Assign a value to an object variable, then extract the same value from the object. So this 2016 gets inserted into the object into the year variable right there. Myride says go to the reference, and inside the reference, go inside the object and access the year variable. No parentheses after the dot year. We are directly accessing the variable year within the object. Objects have variables inside them. Objects have methods inside them. If you don't see a parentheses here, you're accessing a variable within the object. JavaScript and the C# languages allow direct access to object variables. You'll see a lot of code like this if you're writing in JavaScript or C#. But Java, not so much. Java says we don't like you accessing the variable directly. The class designer in Java gets to decide if access is allowed. So the class designer decides if I'm going to let you access these variables directly. And if they say no, you're going to have to use methods instead of directly accessing the variables. It's good object-oriented programming design. It says make objects user call a method to do the same thing. So the next two lines of code do basically the same thing as the previous two lines of code. But this time we're going to use a set method to assign a new value to a variable, and we're going to use a get method to get the value from that same variable. Set methods have an input parameter the same type as the variable it is setting. The pattern holds here. Year is an int. Notice how this is int year. So set year must take an integer parameter. It does. What does it do with that integer parameter? It assigns it to the year variable. and you can see the 2018 showed up in our object. Get methods have an output or return type the same as the variable it is getting. The pattern holds. This method returns an int. When getYear is called, it will send an int back, and you can see I'm assigning it to YR. This line of code put a 2016 in, and the next line of code pulled the 2016 out. This line put 2018 into the object, and the next line of code pulled it out and assigned it to YR. SetYear has an int input, getYear has an int output. That's because year is declared type int. Int input, int output. The name pattern also holds. The variable is called year, so the methods are called setYear and getYear. Once you know the pattern, writing more get and set method is easy. Code generators do this easily. They write them all the time. There are utilities or programs that say, hey, name me the variables and I'll spit you out a class with the variables and the set and get methods already written. Set methods should verify input. One of the things we're not showing in here is a good set make would make sure that you gave it a good value like Honda, Toyota, Chevy, Ford. A good set year method would make sure that the year was reasonable. They didn't build cars before 1900, so the earliest cars would be 1900, and probably you don't want to do anything past the current model year. But that depends on whether or not you're looking into the future. Think of objects as mega variables. They can store multiple pieces of information. A car object variable holds 3 pieces of information: make, year, and cost. Set methods put values into these variables, and get methods extract or pull values out of these variables. Follow the pattern. If it's an int variable like year, set year will have an int parameter, and the get year will have an int return type. Last variable, cost. myride.cost equals 9499.00. Assign a value to an object variable, then extract that same variable from object. So 9499 is being inserted into the cost variable. It goes to myride.cost, and there's my new value in the cost variable. I then take the value out of that cost variable and assign it to the variable COS. So this puts the data into the object. This pulls it right back out and assigns it to this variable COS. Notice there's no parentheses after .cost. We're directly accessing the variable in this case. Once again, JavaScript and C#, if you're coding in those languages, they let you do this all the time. Java, not so much. Java tends to discourage this. It's the designer of the class's option to say, will I allow users to use this? Good OOP design says make object users call a method. Java would prefer if you use methods to change the variables. And that's what these 2 lines of code do. Set methods assign values into object variables. If I call set cost and pass it 4999, the 499 will show up inside my object. Set methods put new values into the object, and there's my new value in the object. What does a get method do? Get methods return values from object variables. The variable cost value, 4,999, is returned to the caller and assigned to COS. You see the pattern? Set methods have an input parameter the same type as the variable it is setting. The pattern holds, cost is a double. If cost is declared a double, then its input parameter better be a double. Get methods have an output or return type the same as the variable it is getting. Pattern still holds. If cost is a double, get cost will return a double. Set cost has a double input, get cost has a double output. There's also a name pattern going on here. If the variable name is cost, then the methods are called set cost and get cost. That's telling you, oh, I have a variable named cost. It has the type of double. It's not hard. An object is a variable that has variables and methods. Sometimes you can directly access the variables with a dot variable name like here. But Java usually makes you use get and set methods to change the variables. Java would prefer if you change your variables and access your variables using set and get methods. Learn the get set pattern. Once you know the pattern, using an object is a simple matter of reading the documentation and finding out the variables and methods. You don't have to be an expert on the class in order to use that class to build and use an object. Game engine objects. In object-oriented programming, a primary goal of OOP is code reuse, where the program starts with the classes and objects that someone else wrote and builds their program on top of the provided code. This can lead to rapid development. Since the programmer does not have to write every line of code, the program can be completed faster. So beginning object-oriented programmers are often provided a set of classes and objects, and they say use these classes and objects to write a program. Well, that's exactly what game engines do. Game engines like Unity or the Unreal Engine. An engine provides a set of classes so a game programmer can create and customize objects to rapidly build a game. The key is understanding the classes and the objects they build. This slide will look at a generic engine and the classes and objects it provides to a game developer. I'm not going to go very specific here. I'm going to say in general. The goal here is to learn object-oriented programming and use game engines as an example. Once you understand how object-oriented programming works, then it becomes much easier to program with a game engine. So let's understand how OOP works first. Game engine objects. First things first, this black box represents the outer edge of the screen or monitor. A game played in full screen mode would stretch from edge to edge. See this black box? Full screen mode, the game takes up the whole box, the whole screen. But not all games are full screen and will play in a smaller window. So most game engines start with some sort of window class. They'll provide a class that puts you up a window to play your game in. By the way, the top left being 00 over here, and the screen resolution being 800 by 600 are just examples. I'm not trying to say all games are running at 800 by 600 run. It's just one example. One of the best things about game engines is they handle all those details for you. They handle the differences when it comes to screens and resolutions and operating systems and platforms. Is this a game for the PC or the phone or a game console? Game engines handle a lot of the details for you, and they do it by providing classes that do most of the work. You just build objects out of your classes and you're off to work. Now, I'll display the objects over here. Remember, the object is a memory that is allocated in RAM to hold the reference and the object variable. So I'll be showing you your object examples as they would take up computer memory over here. I'll use code examples displayed down here. I'm trying to use very, very short code examples in this example. That's why it's not going to be a perfect game engine tutorial. I'm here to teach about objects, not necessarily the details of game engines. But you got to understand objects to understand game engines. Let's start with a window frame. Window frame equals new window. What are we doing here? Well, there's that new operator. What is that telling you? New is saying we're allocating an object and assigning a reference to that object to the frame variable. Frame is a reference variable. It points to or refers to an object. A reference is a small piece of RAM. Notice how the object is a much bigger piece of RAM. Objects have variables. Variables define what the object is. A window can be described by its size and location on the screen. What's happening here? A window represents something that's going to pop up on the screen. Well, that thing that pops up to the screen is going to have an X and Y coordinate. Where is it located on the window? It's going to have a width and height. How wide is it? How tall is it? Notice also this fifth variable, visible. If it's false, it means the window is not on the screen at this point. Objects also have methods. Methods define what the object does. A window can change its size. A window can change its position on the screen. A window can change its visibility. These are all things a window does. It is typical that methods operate on the variable values. The job of a lot of these methods is to change the values stored in these variables. Frame.setSize 600 by 400. I'm going to take these parameters, send them to the setSize method, and the setSize method is going to change the width and height. Methods change variables. Go to the frame reference. The dot says go inside the frame object and run the set size method. Change the width to 600 and the height to 400. Now I've drawn the edge of the window as a dashed line because with visible equal to false, I am not actually displaying this window yet. But clearly I'm setting up for a window that's going to be 600 wide. See, X is 600 here. And 400 tall. See, Y is 400 right now. Now, what set that size? Changing these variables is going to set the size of the window. Frame.set position 100, 100. See these parameter values, 100 and 100? Send them off to the set position method. What is the set position method going to do? Assign them to the X and Y variables up here. This is saying I want my window to have its top left corner at X equal 100, Y equal 100. And you can see my dashed line move down to the middle of the screen. This is where I want my 600 by 400 window to be displayed from. That is the corner of the window. Methods change variables. Go to the frame reference. The dot says go inside the object. Run the set position method and change X to 100 and Y to 100. Note how the 100, 100 moves from the parameters to the method to the object variables and is eventually going to be reflected on the screen when this window becomes visible. Again, I use a dashed line because visible equals false, showing where the window will be displayed when it becomes visible. Bang! Visible set to true. The window pops up on the screen. Go to the frame variable. The dot says go inside of it and execute set visible. Pass it the value true. The value passed to it will be set into the variable, and voila, our window shows up. The window pops up, the frame will have its own X and Y coordinates. What am I saying here? Now, this is the screen coordinate. The top left corner is screen 0, 0. When you pop up a window, the window is going to have its own X-axis, its own Y-axis, and of course the top left, in Java's case, is going to be 0, 0. Not the only variables in this class, X, Y, width, height, and visible. Also, the methods are simplified. All I want you to do is see how the values in the object directly change the screen. Keep this class and object in mind as we move forward. When items are placed on the window, we're going to send it to the frame. This is an oversimplified window object. This is a small number of variables that would be part of this class. This is a small number of methods. There will be more. We will be using or assuming there are more as this slide goes on. So we have our window frame. I didn't draw the whole object because I ran out of room, but this frame puts up this window frame right here. Now what we're going to do is create a player object. Player, lowercase player equals new player. We're going to create a player object. The player character, or PC, is the main character of the game. It's the Mario in Donkey Kong, or the Duke in Duke Nukem. All game engines have a way for you to specify who the main character of the game is. That's called the player character. Once again, these variables here and these methods here are not the only variables and methods that would be in this class. This is a simplified version so we can see it on the screen. You need to understand what a player object is before you need to know the details of the player object. There may be X, Y, and width variables in here. That could also be part of the object, but I had to kind of shove them to the back so you didn't have to look at 10 different variables. Every game engine provides some type of class or object that will respond to the keyboard or controller commands. That's another way you can tell about this is the player character. The player character is the character in the game that when you move the up arrow, it goes up. When you move the down arrow, it goes down. This is the main player. It responds to the game controller or keyboard inputs. Also, keep in mind, I've said this word pattern again. Right? What is the pattern? We're going to create a new object. We're going to set the variables in the object, and we're going to show things on the window. That's what we did with the window class. That's what we're going to do with the player class. Player.setName to Slayer. I'm going to take the parameter Slayer, pass it to the setName method. What's the setName method going to do? go up here and insert the value into the name variable. When setting up a player profile, many games offer a choice of characters. You've seen this. The game starts up, it says which character you want to play. It puts up a screen with like 8 different characters on it, and you move the cursor or the controller to say that's the one I want, and you say select that character. That's what we're doing. This person selected the character Slayer. To keep it short, I send a simple hard-coded string here. But strings can be used to determine many different variable values not shown. If I pick the character Slayer, that might tell me that this is a male gendered character. It might load the images for the Slayer character. It might have special powers. It would load all sorts of information about the Slayer object. The more vars reminds you there are a lot more data like the graphics displayed on the window stored in the player object. These are just 2 of the variables that would be in this class. I'm certain there are more. Player.setWeapon, pass it squirt gun. Pass the parameter squirt gun to set weapon. Set weapon, then we'll insert the value squirt gun into the object's weapon variable. Sending a hard-coded string squirt gun and setting the weapon variable. But object variables can be references to other objects. Everything in the game is an object. That's what game engines do. Everything you put on the screen is an object. If weapon is a separate object, it would be much easier to swap weapon. Object variables can be references to other objects. What I'm trying to say here is this doesn't have to be a string. What if this was a weapon object and I sent it to there and this was a weapon object variable? The more methods right down here reminds you there's a lot more methods. There should be some sort of draw method in here that draws the player on the screen. There'll be a lot more methods and a lot more variable in this object. We're trying to keep it simple so it becomes a little more understandable. Next line of code is quite interesting. Remember that window frame that we created on the previous slide? That's what put up this window on the screen. We're going to go to that window frame and do a .setPlayer and pass it the player variable. We're going to say, you know what? I want this player variable to be sent to the window frame so the window frame knows who the main character is. So we're going to add the player object to the window frame. When the window draws a screen, it will use this reference to call a draw method, which will draw Slayer holding a squirt gun. We're telling the window frame that I want the main character to be Slayer. He's holding a squirt gun. Draw it on the screen. And we're doing it through this object right here. Object variables can be references to other objects. These variables inside a frame and inside of players, they don't have to be simple strings or ints or doubles. They could be references to other objects. Everything drawn on the window is an object, and the frame will contain references to all of them. Enemy bad guy 1 equals new enemy. It's a vampire at 2010. The final game engine class is called enemy. This is what's called a non-player character, or NPC, that the player object does battle with. Anything that does damage to the main character is considered an enemy. In a Mario-style game, it could be a barrel or an anvil. Enemies are just defined as things that try to hurt the main character of the game engine. On this line of code here, we're going to create an enemy object and assign it to the object reference bad guy. So here's the enemy object. And here's the reference assigned to bad guy. Now, we're doing something different this time. We're going to pass values to the constructor methods like vampire 20 and 10. And these values, as you can see, get inserted into the variables of the object. Rather than calling other methods to set vampire and set the position, we'll just pass it to the constructor and let the constructor initialize these variables. Frame.addEnemy bad guy 1. Once again, this is the window frame, and everything I want to go on the screen, I got to tell it, put it on the screen. So what I'm going to do is I'm going to add a reference to bad guy 1 into my enemy list. What does that do? That's going to pop the enemy up on the screen. Go to the window frame and add bad guy 1 to the list of objects to display. Once there, every time the window is updated, bad guy.1 will draw and execute. Everything on the window is an object. Each object must contain all the data needed to draw itself on the window. Well, if bad guy is inserted into the frame, then when it's time to draw the frame, it'll come down here, execute the draw method, and say at x20, y10, draw a vampire. And I put text in here because I didn't have much room, but it's drawing this vampire on the screen. Now, enemies don't stay still. They might move around the screen. What I'm going to do here is bad guy 1.set position 3020. I'm going to change the x and y coordinates, and that's going to move the vampire. The vampire used to be here, and it moved to here. Enemy movement is a simple matter of changing the x, y values in the enemy object. The call below is too hard-coded for me. I don't like this 30 and 20. But, I got to keep the code short so you can see it. But in an actual game, each enemy object would have an internal move method called automatically by the engine, just like draw is called. Move would look at the type of variable, type of object that it is. Oh, I'm a vampire, and it'll move a vampire the way a vampire should move. Now I'm speeding things up here. I don't have room or time to show all the different objects. We've already looked at how enemy objects work, so let's just speed it up a little bit. Bad guy 2 equals new enemy, and this one's going to be a zombie at 305. Bad guy 3 equals new enemy, and this one's going to be a mummy at 20, 370. And then I'm going to the frame, I'm going to add enemy, I'm going to add bad guy 2, and I'm going to add bad guy 3. So in the end, the frame is keeping track of 3 enemy objects, bad guy 1, bad guy 2, and bad guy 3. Want more enemy on each level of the game? Simply build more objects and add it to the frame. Note, each object has its own type, its own x and y values, so the draw places different images at different locations. The move method would also be customized for all 3 of these different types. But if vampire is at 3020, that's where the vampire will be drawn. If bad guy 2 is a zombie and is at 300, 5, well, 300 is kind of the middle of this window. 5 is near the top. That's where we'll draw a zombie. What about the mummy? The mummy is at position 20, 370. Mummy is at x20, which is very close to the left side of the screen. y370, which means it's down near the bottom. And there's our mummy being displayed on the screen. Many games are object-oriented video games, and pretty much everything you see on the screen is an object. In a Mario-style game, Mario would be an object. The barrels rolling down the screen would be objects. The monkey or the gorilla would be an object. Everything is an object in an object-oriented video game. And what you do is you create the object, you put the information about that object inside of it, and then you say, hey, put it on the screen for me. All you really need to know is how to build an object and how to call the methods of the object, and you're off to the races. This example might seem complicated, but it is following a simple pattern. You read the game engine documentation. You find the class to create what you want, you build an object, you insert values in the objects, and you place that object on the window. That's about it. I build a window object, I set the values in it, and I say show the window on the screen. Then I start building characters. I build their objects, I put values into their objects, and I insert them on the window, and boom, the game engine does the rest. There it is. I hope you've got a good understanding of how objects work. Now that we kind of understand how objects work, let's go on the next lesson and learn about classes and writing our own classes. Have a good day. I'm Professor Chris Ferguson.